Let's begin. 8.3 are dealing with the third type of rigid motion you're supposed to know. So far we've learned three transformations. We've learned in section 1, we learned the thing called translations. It's where it's a slide. We learned the second one in section 2 we called reflections. The third one is a rotation, which is where we are going to spin the object around a fixed point. So the very first thing I need you to remember are rotations are rigid motions. Rotations are a rigid motion, meaning it's not going to change its shape. It's going to stay the same size. And so I'm going to give you a couple of words that we're going to use when we do rotations. The first word is origin. I use this all the time. We've talked about it before, but just in case you've forgotten, I always like to write down what words mean. The origin is the point 0, 0. Here's a little picture for you. If you need to know what the origin looks like, I'm talking about this point right there. That's the origin. 0, 0. It's where the x and the y axis cross each other. Most of the rotations that we do, as a matter of fact, in Math 1, we only do rotations around the origin. We're going to rotate around this point. And so we got to know what that point is called. There it is. In Math 3, you're going to start rotating around a fixed point, something other than 0, 0. But right now, we're only going to do rotations about this point. We're also going to need to know the difference between clockwise and counterclockwise. Clockwise and counterclockwise. So I'm going to draw a quick clock real quick for you. That's my fake clock right there. If I was a watch company, they always like to show you the time 10, 10, by the way, because it looks like a smiley face. So if you ever look at a watch ad, like there's an advertisement for a watch that has a second hand, usually they will have it in 10 o'clock, 10, 10, because it looks like a smiley face to subliminally let you be happy to look at their watch, right? Clockwise means you follow the red hand and you go this direction from the top to the right. It's like what's happening on this clock up here, where that red hand, it goes tick, 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 tick. It's going around this way. It's where the top goes to the right. This is also how most objects are turned when you turn them to tighten them. If I'm trying to tighten a bolt, I go righty-tighty. It's clockwise direction. Counterclockwise, you're going the opposite direction. You're going to the left, from the top to the left. So we have to know which way is clockwise and which way is counterclockwise, because we're going to tell you to rotate things clockwise or counterclockwise. And so I have a little cheat sheet for you. Couple of other things that we need before we need to know degrees, how far or what it looks like for a certain amount of degrees. Okay? If I tell you to rotate 90 degrees, this is what 90 degrees looks like. From here to here is 90 degrees. That's 90 degrees counterclockwise. One quadrant. I could also do 90 degrees from there to there. That's also 90 degrees. Anytime you go from one axis to the next adjacent axis, that's 90 degrees. 180, on the other hand, is where you go from one side of the axis to the other side of the same axis, either clockwise or counterclockwise. The last one that we're going to do the example of is a 270. And if I went 270 degrees, I would go all the way around from here to there if I was going counterclockwise. And then if I was going clockwise, I would go this way, 270 degrees. So I'm going to label these. I'm going to put clockwise on the ones that are going clockwise. And then the counterclockwise, I'm going to put CC, counterclockwise. C for clockwise, CC for counterclockwise, just in case you need to know. CC, C, CC, C. Very, very basic stuff. You probably have done this before. So I'm not going to write too many. We're just going to write how to. Number one, trace the object. Trace the object. And the axes. Label the points. Trace the object and the axes, A-X-E-S. Trace the object and the axes and label the points. Second thing you're going to do is rotate your patty paper. Have you done that before? Use that stuff? You're going to rotate your patty paper however many degrees. The correct degrees. Rotate your patty paper the correct number of degrees. So, the third step that we're doing is going to plot the image using primes. So I'm going to give you an example, and this is literally just like last time. You had to do notes, a notes worksheet, and then a homework worksheet. You're going to have the same thing for 8.3. My example for you is going to be, 8.3 notes number 1. That's what my example is going to be. I'm not going to have you draw that out here. If you want, you can get your packet out right now and we can look at 8.3, number 1, and we're going to show you how to do that with these 3 steps. If you have your packet, it looks like this.
Did you say 8.3 has some worksheets too?
It has a double 8.3 notes and a double 8.3 homework. So it's 4 pages technically. Be about the same amount of time. So if you have this, what we are going to do is we're going to follow those 3 steps on how to do a rotation. Your worksheet's going to ask you to give the coordinates for Q, R, S. So Q is at the coordinates. What's your X coordinate first? What's your Y coordinate second? What are you going to put here? -5, comma 6. If you didn't know, you're going to go through and label what R is. You're going to put the X first, then the Y. X first, then the Y. Then you're going to do the S. Then X first, then the Y. The R should be at 0, 4. The Y should be at -1, 1. Does that sound correct to you? Then what you're going to do, we're going to follow this 3-step plan that we just wrote down. 1, trace the object and the axes and label the points. It looks like this. I take this. I take my patty paper. I like patty paper. If you've never seen this before, this is the kind of paper that goes in between hamburger patties. And it also is in between very fancy cheeses. If you put like a fancy cheese between another not super fancy, but it ain't. It's not American. It's not Kraft American cheese. This is good cheese. You'll have patty paper between it. Okay. This stuff really is like weird because look at you can't see it. You can't see it until you lay it down, and then you can see through it. Look at how magical that is. Wow, magic. Can't see it. There it goes. Magic. Weird. So it's perfect for tracing. I like it because it's thin enough you can kind of see through it when you lay it down. We're going to trace the object, and I'm going to recommend you take your patty paper and you're just going to, because you're going to do more than one here. We trace everything, the axes, just like that. See how I trace the axes, and then I trace my points and be very accurate, as accurate as you can be. Here's Q, here's S, here's R. And if you even want, you can use rulers, which I have rulers for you. There's that. Tracing it still. Just like that. And if I move, I can see is my trace looking pretty accurate. Yeah, it's pretty good. Okay. It tells me here, rotate QRS counterclockwise about the origin. Here's that word. That's 0, 0. So I need to go in which direction? Does that mean top to the left or top to the right?
Top to the left.
Top to the left. So I'm going to take this and go how many degrees?
90.
That goes from one axis to the next axis. That is a 90-degree turn. Just like that. 90-degree turn. And notice that my origin lands on my origin. It stays the exact same spot. In Math 3, you will end up rotating around a different spot. Like you might rotate here, and then you'll do something like this. Okay? But what we're going to do is we're going to rotate right here, and it all rotates around. Look at how wonderful that is. That's such a cool thing right there. And so I'm going 90 degrees. And then once I have this, I'm going to do number 3. Number 3 says what on your notes paper? Somebody read that for me. Plot what?
1C.
Plot your image using prime. So here's what that means. Here's your new R. Your R was there, and now that R is here. When I go and I figure out where is R going to be, R is going to be right here at this -4. You're going to put a dot there and put R prime. R prime, like that. And then what you're going to do is you're going to see S was at -1, 1, and then you're rotating it, and now your S prime is at -1, -1, S prime. And then where is your Q at? Your Q is going to be over here at -6, -5. And then you can use your ruler again to connect your dots. And you're going to get your image. And this is Q prime, R prime, S prime. Don't forget to put the primes because then you know that you've made the transformation.
Are we going to get to use that stuff on the test?
Yes. I will give you guys patty paper. And notice, I have on my patty paper, I have one here. So if I need to do it again, I can rotate again if I need to. I can use the same one. Or I have another corner to do a different rotation with a different triangle. Or this one, I can just use the patty paper more than once. Make sense? So you're going to be doing rotations. And that's how we're going to do the majority of our problems. I'm going to give you a couple of hints. As you do your problems with the patty paper, the rotation parts are going to be easy. What's going to be hard will be the coordinate notation. Question, Ray?
There's an easier way to do this in this whole patty paper thing.
Some people can do it in their head, Ray, but that doesn't mean everybody can do it in their head.
But it's like, you just have to know.
No, hey, I know. But just because you understand it that way doesn't mean everybody understands it that way. Okay? Just so you're aware. This method I am showing you is an easy method for the majority of students. If you are a person who can do this in your head, I am fine with that. You don't have to use the patty paper. I'm okay with it. But I'm giving a method that's going to work for anybody who may need a little extra help. That's what it's for. Okay, so now we're going to graph the transformation. Here's a question, and I want to do example number 4 with you. Example number 4, I'm going to add this to the notes page. If you want to look at this, it says graph xy such that negative x, negative y. I want you to know what this means. You do know what it means? Okay, well, but give me a chance to explain it, okay? So I'm just going to do a rough sketch real quick, and I want you to really, as you do look at these coordinate notations, it's something that you're going to get a lot better at as you do more of them. Okay, I'm just going to do a quick sketch. If you want to look at your actual number 4, you're welcome to do so. Boom, boom. I'm going to put a point right there. I'm going to put a point over here at 2, -1. 1, 2, -1. I'm going to put a point at 4, 3. 2, 3, 4, 2, 3, 4, 3. Okay, I'm going to even label these things. 4, 3. This is at -1, 1. This is at 2, -1. I'm just going to label those points so you can see them. And that's kind of hard, so let me zoom in a little bit more. That's my sketch. That's my sketch of what of what's on your paper. When you see this, it's telling you, this is the rule. Take your x's, whatever your x is, and don't do the negative x. What this means is do the opposite of whatever your x is. Do the opposite. So when you see a negative x in coordinate notation, it's telling you to do the opposite of the x. It's also, if you see a negative y, it's telling you to do the opposite of the y. What does that mean for this picture? Every x becomes the opposite x. Every y becomes the opposite y. So for this point right here, 4, 3, instead of me using 4, 3, we're doing the opposite of 4. What's the opposite of 4? -4. And what's the opposite of 3? So this point right here becomes -4, -1, -2, -3, -4, -3. This point here comes over here. Bam. And I can even write that, -4, -3 right there. Now, I have to do that for every xy. I have to take this 2, -1, and I have to make this x the opposite. What's the opposite of positive 2?
-2.
And then I have to do the opposite of -1. What's the opposite of -1? So I'm going -2, +1, which is over here. And I'm going to put a little arrow because I ran out of room there. -2, +1. I have one more point to do, which is this -1, 1. I have to do the opposite of that x. What's the opposite of -1? And the opposite of that one. 1, -1, I believe is right here. 1, -1, and I'm going to connect these dots. And I have this red shape. Pretty neat. Okay, now let's be more specific, because this question doesn't ask this question, but I want you to know. If you have an xy and you make it a -x, a -y, does that rotate this object?
Yes.
It's a rotation. How many degrees was it rotated? Do you know?
180.
180. So if I want to ever do a 180-degree rotation on an object around the origin, I can use this formula. I'm going to put over here that this is a 180-degree rotation. Notice I did not say it's a counterclockwise or a clockwise 180-degree rotation. Why didn't I say it? Because if I went clockwise, I end up here. Or if I went counterclockwise, I would end up in the same spot. It doesn't matter for 180. It does matter for 90-degree rotations and 270-degree rotations. Question?
I'm just clarifying something.
Perfect.
It's kind of not related.
Okay?
Well, it's 50-50. So I'm just checking my formulas real quick.
Okay. You want to see if your formulas are correct.
So for 180, I have -x and y.
Okay.
90 degrees counterclockwise, I have -yx, and I have -xy for 90 degrees clockwise.
Okay, so just remember there's going to be a difference between clockwise and counterclockwise. Most of this worksheet is going to deal with counterclockwise rotations. And the reason they do counterclockwise rotation is because in Math 2 honors and in Math 3 honors, you start doing the quadrants counterclockwise 1, 2, 3, 4, just in case you didn't know. You're writing them down for clockwise. I don't know them in that way. I know them for counterclockwise. Just,
I have 90 degrees counterclockwise and 90 degrees clockwise.
I have those written down somewhere. Where did I put them? Oh, here they are. So let's end our notes with this last little cheat sheet that might help you, which is what Ray is reminding me right now. Let's do counterclockwise. Counterclockwise. Can't see it. Thank you for telling me that. Counterclockwise. If we have a 180-degree rotation for counterclockwise, we're doing XY moves to or transforms to, let me move that over just a little bit more. That's a 180-degree rotation counterclockwise. Let me do a 90-degree rotation. What'd you say, Ray?
-yx.
That's true. That's what I have on my paper. And then we have a 270-degree rotation.
It doesn't matter which way.
It's all counterclockwise. This is this is my cheat sheet for counterclockwise.
That's probably -xy.
That's not what I have.
Or y -x.
I have y, comma, -x.
Okay.
Okay. You'll start to notice these as you do more problems. Okay, I'm going to end your notes right there.